Let's have a look at a problem from the rational functions handout that I sent. So it's the integral of minus 2x plus 16 over x squared minus x minus 6. So I definitely could not guess an antiderivative for this. So let's see what we can do. Hopefully it occurred to you after the first example from the worksheet that if the denominator factors, it's probably a good idea to see how it factors. And it looks like this one does factor. It's x minus 3 times x plus 2. Okay. And by looking at the earlier examples on the worksheet, the idea of them was to give you the idea that if there are these factors in the denominator, hopefully we can split this fraction up somehow into two fractions, each of which has one of these two factors in its denominator. So something like this. Hopefully we can arrange it so that minus 2x plus 16 over x minus 3 times x plus 2. Hopefully we can figure out some way to have two fractions where the first fraction has x minus 3 in its denominator and the second fraction has x plus 2 in its denominator. And we don't know what the numerators should be, so let's call them capital A and capital B. All right. Well, it turns out that we can make this true by choosing appropriate numbers A and B. The trick is figuring out what those numbers should be. This is a process, finding these numbers is a process called partial fractions, and this right-hand side is called the partial fractions decomposition of the left-hand side. And you can see, if we can make this happen, if we can find A and B, then we can turn our integrand into this sum of fractions, and we can integrate each piece, because each piece is simpler. Okay, so all we need to do is figure out what is A and what is B. Now the key here, key trick, is just to clear denominators. Okay, so we're going to multiply both sides by x minus 3 times x plus 2. And on the left-hand side as well, multiply by x minus 3 times x plus 2. Okay, now on the left-hand side, everything cancels. That's convenient. So we get minus 2x plus 16. And on the right-hand side, you have to be a little careful. First, distribute this thing that we're multiplying by to each piece. And in each term, part of the expression we're distributing cancels, but not the whole thing. In this first term, the x minus 3 cancels, so we get a times x plus 2. And in the second term, the x plus 2 cancels, and we get b times x minus 3. Now it might look that there are just too many, it might look like there are too many variables to make any progress on finding a and b. After all, how do you find two unknowns, a and b, when there's actually a third unknown and you only have one equation? Well, the key thing here is this equal sign in the middle is supposed to be true for all values of x. So we can come up with lots of equations, as many equations as we want, just by picking different numbers for x and putting them in here. So for example, if you're clever about how you pick your x values, you can make the resulting equations very easy to solve for a and b. So let's try x equals, we can pick any number we want, but I want minus 2. And the reason I want minus 2 is because when I put minus 2 in right here into the x plus 2, it's going to make that part 0. Okay, so let's plug in minus 2. we get minus 2 times minus 2 is plus 4 plus 16 equals a times 0, excellent, plus b times negative 5. All right, so 20 equals negative 5b. So b looks like negative 4. Excellent. So there's one of them. We know b. Well, that worked so well, let's do it again, but with a different x value. This time let's pick an x value that makes the other part 0. So how about x equals 3? So we get negative 2 times 3, that's negative 6, plus 16 equals a times 3 plus 2 is 5, plus b times 0. So we get, let's see, 10 equals 5a, and that gives us a equals 2. All right, so now we know a and b. And remember, a and b were the numerators for each fraction term here. So a is 2 and b is negative 4. So now that we know those numerators, we can finally go back to our integral. Remember, this was all about that integral. So that integral was, integral of negative 2x plus 16 over x minus 3 times x minus 2 dx. So let's take this, bring it on down. Now we can rewrite this. It's the integral of a, which is 2, over x minus 3. There we go. Plus b, which is negative 4, over x plus 2 dx. All right, so we've replaced our difficult integral of a rational function into this easier integral with two rational functions. But these two rational functions are so simple that we can integrate them directly. You might need to do a little substitution. So for this first one, you might need to do a u substitution with u equals x minus 3. And then when you're working on this second one, you might need to do a little u substitution with u equals x plus 2. So if you need to do that to work it out, go ahead and do so. But what you end up with for this first one is 2 times natural log absolute value x minus 3. And then for the second one, minus 4 times natural log absolute value x plus 2. And this was an indefinite integral, so of course plus c. All right. So the key idea here is, if you want to integrate any rational function, all you need to do is find its partial fractions decomposition, because the partial fractions decomposition will be a sum of individual terms that are easy enough to integrate one by one.